Hello everyone, today I'm going to solve this problem. Please pause this video and read this question very carefully. In this problem, we have to find the velocity at position B. The collar A is sliding on the rod and it reaches at the point B. So I'm going to write all the values for the mass, the spring stiffness, and especially the unstretched length of the spring, which is, we can say, that original length of the spring when it is in the rest condition. So it is 1250 millimeter. Now let's solve this problem by using kinetic energy and work formula. I want to highlight that the velocity at the position A is 0 because in the problem it is said that it starts from the rest. So we can say that velocity at position A is 0 and then kinetic energy at position A will be 0. So let's write the formula for work and energy. We can write the kinetic energy at the position A plus the work done from A to B and the work by a spring or elastic is equal to the work at position or kinetic energy at position B plus the spring work at position B. Now we are going to solve each part of this equation. So as you know that velocity at position A is 0, so the TA will be, or kinetic energy at point A will be 0. Now we have to calculate the work done by the spring, and we will come back to the work U-AB later. So we can write the work done by spring is 1 by 2 kxa square. Xa is the deformation or elongation at the position A. So let's calculate the xa, which is the elongation or deformation, total elongation or deformation at position A. So I will write a very simple formula here. The original length of the spring, it means that the unstretched length of the spring minus elongated or deformed the dimension of the spring. So original length of this or unstretched length of the spring is already given 1250 millimeter. So I will write here 1250 millimeter minus the elongated or deformed. So if you see the position A, the length of the spring at this position or condition is just 1000 millimeter. So you can see here in this picture that distance from A to O is how much? Just 1000 millimeter. So we can say that the total deformation at this position at A is 0.25 meter. Now let's move and calculate the work done by the gravity and other forces we can see here. So at this position we can see here that only the work is done by the gravitational forces or the mass of this body. So we can calculate work done using mgh formula. Now boys and the girls, let's see mgh will be positive or negative here. So the mass is going downward direction, so we can say that work done will be the positive because of the gravity, it's going downward direction. When it will go up, it will be negative, but here it is going down. Okay, so now we will solve the equation 1 and make sure that you use vertical height of the edge in when we are calculating work due to the gravity. We always use the height in vertical direction, not inclined, not curved, nothing, just straight. Okay, Now let's calculate the kinetic energy at the point B and the spring work at point B. So kinetic energy at position B is very simple, half mvb square, and we assume or we are expecting that what will be the velocity when it will come to the point B. We are not talking about it stops there or what happens. And the secondly, we have to calculate the spring work, that will be 1 by 2 kxb square. So what is xb? It is original length minus the elongated length. Now here is a catch. How much is elongated? So you know that the elongation, it is in the purple color. Okay, as I am making here, sketching here, this is the elongated length. So what is this? This is not given. We have to calculate this. And how we can use the theorem here? Just make a triangle and you can calculate the hypotenuse here. So 1500, that is 1000 plus 500 is 1500, and on the bottom side there is a 900. These are given in the information in the image. So you just calculate the hypotenuse here and you can easily calculate the value of xb. This, make sure that you calculate the total deformation, okay, in a correct way. Find the actual or the rest condition of the spring or unstretched condition of or dimension of the spring. What is this is always given in the problem. And to know the elongated or deformed length, you have to find this in the problem. This is always, you will find this type of problems in the book. So here answer is minus 0.499 meter. Now we have all values. Now we will solve our equation 1. So I will write the whole equation again. As you know here that kinetic energy at position A is 0 because it starts from the rest. Then the work is mgh and the spring work is half kxa square is equal to half mvb square plus half kxb square. Now you have all values. You know what is the value for m. So I am going to write 1.4 multiplied by 9.81 and 0.5. 0.5 is a vertical length, the h. Then I'm going to write the spring factors here. 1 by 2, 60 multiplied by 0.25 square and the rest values. And here you can see that VB is unknown to us and other values are given to us here. Boys, if you have any other questions, please write in the comment. Please don't forget to subscribe and share with your friends. Let me know if you have question or any problem. You can write in the comment section. I will try to solve it. So with this equation, everything is clear. Just unknown is the velocity at position B, which can be easily calculated here. So you can use your calculator and simply calculate the velocity at position B is 1.348 meter per second. So thank you very much. Let me know about this video. When you are solving this type of problem, you have to be very careful in finding what are the work done. For example, UAB, what type of work can be added, if there is a friction or not, if there is a spring, if it is falling down. Okay, please don't forget to like and subscribe. Thank you very much.